Hi guys! In this lesson we are going to talk about points, lines, and planes. The objective of this lesson to understand the basic terms and postulates of geometry. Let's see what we have. We have a lot of vocabulary, and the vocabulary are point, line, plane, collinear points, coplanar, space, segment, ray, opposite rays, postulate, axiom, intersection. Once we discuss about the meaning of this vocabulary, we will feel it's easy to learn and use. So we have here undefined terms, which means just we have description for them. We don't have any definition for them. So a point, what is the meaning of point? A point, it indicates a location and has no size. So the point, you can see here, as we have as an example, a point is this one. It's just a dot, and then you can represent it by using a capital letter like A, for example, B, and so on. Any capital letter and a dot, this is a point. A line is represented by a straight path that extends in two opposite directions without end and has no thickness. A line contains infinitely many points. So we can represent the line like this. That's how we have it as a diagram. So we have here AB. We can represent this line by saying AB, and we put on it a small line like this. We can say the opposite, BA. It will give the same meaning. Also, we can say line L. We can say, as it's named here, line L. So we can read this line by saying AB like this, or saying BA like this, or by saying line L. Now, a plane is represented by a flat like this. A flat surface that extends without end and has no thickness. A plane contains infinitely many lines. We can represent this plane by capital letter such as this P. So the name of this plane is P. Maybe we have another name sometime in another example. We can have it, for example, A, B, C, L, any capital letter. It depends on your example. Also, we can represent it by another way. We can represent it by using 3 points, but not on a straight line. 3 points lie in the same plane, but not on a straight line, like A, B, C. A, B, C, we can just change the order for them. C, B, A, B, A, C, and so on. So like this, or plane P. Let me give you an example. But before we start the example, let me explain for you the meaning of collinear points and coplanar. So collinear points are the points that lie on the same line, like this. While coplanar, the points that not lie on the same lines, but it's on the same plane. For example, if we have like this, so we can have points. So these we can call them coplanar. Now let's see the first example. In the first example, naming points, lines, and planes. What are 2 other ways to name a QT? Where is the QT? QT here. This line. That's what they mean by QT. Right. QT, I can change the order. I can say T, Q, and I will put on it this line. Also, we can say as written here, M, line M. So we can say it's also line M. What are two other ways to name a plane P? So plane P, which is all the surface, we can name it by using three points. So I will use this point and this point, this point. So I can say S, R, V. I can use another 3 points, S, Q, V. S, Q, V. Just use any 3 points on the same plane and then just write them beside each other, and then this is the way. Now what are the names of 3 collinear points? Collinear points which is lie on the same line. So which is lie on the same line, we have these R, Q, S. So we can say R, Q, S, R, Q, S. That's 3 collinear points. Now what are the name of 4 coplanar points? Now coplanar points, let me put coplanar points, which are R, Q, S, and V. So coplanar, the most important thing in coplanar, it lies on the same plane. You don't need to care it's on the same line or not, but it could be on the same line, by the way. So these are the coplanar points. Now let's move to got it. What are 2 other ways to name RS? Where is RS? This is RS. We can say the opposite, SR. We can say also line L. What are 2 more ways to name plane P? We can choose, they said, 2 more ways. So I need to write it in 2 ways. You can use 3 points. So R, Q beside each other, R, Q, V. And we can say QSV. QSV. Now, what are the names of 3 other collinear points? So what is the other collinear points? We have them S, Q, R, V. S, Q, S, Q, V. Also R, we can say. Now, what are 2 points that are not coplanar with points R, S, and V? We can say it's T because it's outside, not coplanar because it's outside, T and N. So it's T and N. Now let's move to the next part of the lesson. So in the next part, let me explain you just some vocabulary before I move. So here we have the meaning of space. Space is the set of all points in 3 dimensions. So space is including the points, segments, planes, everything that we learned, points, line, plane, all these in place and space. If they said here it is not defined yet, because we don't know where are they. We don't know if they are on table, where are they? So that's why we are representing here them by saying space. They are in the space. So point, line, and the plane, they are in the space. Now, let's define more vocabulary or more thing we need them. A segment. Now a segment is a part of a line that consists of two endpoints. So what is the difference between segment and line? Line does not have any endpoint. So it goes from here until infinity, it goes from here until infinity. While segment, there is two endpoints. So a line we represent it by writing A, B, for example, by writing like this, there is arrow here. While segment, there is no arrow on the top. Same thing, you can change the order for AB and BA. Array is part of a line that consists of one endpoint. So array, there is only one endpoint because it goes from this side until infinity. It does not stop here. It does not stop here from this side while it's a stop from here. How can we represent it or name it? By saying A, B, you will start with the endpoint, then you will say A, B, and then you will put line, and there is our arrow on from only one side, from only this side. So that's what should you do. Opposite rays are two rays that they share the same endpoint. So we can see here, this is array and this is another array. They have the same endpoint, which is C, but they are in opposite directions. So CA, which is from this direction, CA, this one, and CB, they are opposite rays. So that's what we have from this vocabulary. Let's move on. Now, let's use these definitions in our example. What are the names of the segment in the figure at the right? Now, I'm using segment. That means it's not line, something, it has endpoint. So we have a 3 segment here. So the first segment, EF, because it's segment, I will put on it only a line like this. There is no arrows. I have also this segment, D, E. Also on the top, you will put a line like this. Finally, we have the last segment, which is this one. So, D, F. Again, you must put a line on it. Now, keep in mind, you can change the order for this one. You can say FD here. You can say FD. It will give the same meaning. Same thing with DE. You can say ED. Same thing here. You can say FE instead of EF. What are the names of the rays in the figure? Now we have rays. How many rays we have? We have also 3 rays. Again, so the first ray is this one, E, F. The only difference, you will put a line on it like this. All right, now, same thing with here. If you start from here, this also array, DF. DF. So here segment, you will put only a line on the top, while here you will put small arrow like this. Now we said DF, EF, and DF, EF, and that's it. You can also have the opposite direction from these two rays, which is ED, 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 which goes like this. Also, you have FD, which goes like this. FD, which is the opposite side or the opposite direction of EF. So you can also write it. Which of the rays in part B are opposite rays? So we have DF, the opposite for it, it's FD. EF, the opposite for EF, which is this one, the opposite for it, it's FE. That's it. You can say also for ED, there is no opposite for this one. Now, let's move on. Now, EF and FE form a line. Let's erase all this and then see what we have. Or let's draw it again. We have E, E, F. That's D. Now, EF this one, and FD FE. This one. They are asking you, are they lines? They are not lines. Why they are not lines? Because they have endpoints. So they are not lines because they have endpoint. So and are they opposite? They are not opposite because they don't share the same endpoint. So no, they are not lines or opposite because this one, because I'm writing this just small short form just to say because they don't have the same endpoint. They don't have Now, we are done from the meaning of points, lines, planes, segments. Now, we need to explain something more than definition. This thing is postulates or axioms. So postulates or axiom is an accepted statement of fact. So postulate, like undefined terms, are basic building blocks of the logical system and geometry. You will use logical responsing to prove general concept in this book. So postulate or axiom, once you tell me, okay, the result is like that. This means I will tell you why. You will say, I'm using the postulate that say blah, 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 blah. And then you will give me the postulate that you are using. But if you say something and you're not using a postulate, that means how can you prove your work or your result? So postulate or axioms will help you to prove statement to make sure it's correct or not. Let me give you just the first postulate. So the first postulate, or let me say fact, that will help you to prove, throw any 2 points, there are exactly one line. Logically, you will feel it's really easy. Yes, throw any 2 points. Can you, if you have these 2 points, can you make another line pass through these 2 points? No, you cannot. If you say, okay, I will do it like, it's on it. It's exactly the same line. So here you have this example. A line T, it passes through A and B. This is the first postulate. Now, intersection. Intersection, what is the meaning of this intersection? Intersection, when you have 2 or more geometric figure, they intersect, when their intersection, it is the set of points the figure have in common. So we discussed also in grade 8 about something like that. Once we solve system and the lines, once the lines intersect in one point, so it was the solution. That was in algebra 1. So the meaning of intersection, which is the set of points that share or common between these 2 lines or between these 2 graphs. For example, if we don't have, for example, 2 lines and we have, for example, this curve. So these point, these intersection, the intersecting point. Now, let's take the second postulate and move to the third example. If 2 distant lines intersect, 2 different lines intersect, then they intersect only in one point. It makes sense. Can you prove that? No, that's logical thing. That's a postulate. The postulate, you cannot prove it. The postulate, it's fact, it's logical thing. You cannot prove it. You will use it in proofs of theorems and other statements. Now, finally, before the last postulate, if 2 distant planes intersect, then they intersect exactly in one line. So basically, if you compare between this postulate and this postulate, so if two intersecting lines, so then they intersect in one point only. While here, if you have 2 intersecting planes, then logically they intersect in a line, not in a point. So they intersect in a line. If here planes, intersecting planes, then they intersect exactly in one line. Let's see what we have here. So finding the intersecting of 2 planes. So each surface of the box at the right represent part of a plane. What is the intersect of a plane ADC? Where is ADC and plane BFG? Let's see, where are they? So ADC, where is ADC? Then this plane, right? Now, this plane is intersecting with BFG, which is this one. So, the question is, what is the intersecting? Then they will intersect in a line, right? So then they will intersect in a line, which is this line. So then they will intersect in this line. Why I'm saying they are intersecting in this line? Because according to the postulate that we just said here. That's it. Now, here, what are the names of two planes that intersect BF? So what are the names of two planes that intersect in BF? What is BF? BF here. Now the opposite. They want me just write the planes that they intersect in this one. So the first one is this one. The second one is this one. Then we can write them as we just mentioned in the beginning of the lesson. How can we write a planes? How can we? By just writing 3 points lie on the same plane. So I can say A, B, the first plane, A, B, F. Miss, can I use the third point, this one? Can I say E, A, B? Yes, you can. Can I say F, E, A? Yes, you can say. There's many ways to write them, but choose only 3 points lie on this plane. Okay, and what about the next plane? And I'm going to choose B, C, G. B, C, G. B, C, G. Now, why do you need to find 2 common points to name the intersection of 2 distant planes? Why do I need to find only 2 common points? So the answer of A is this one. So logically, when you think about it, B, now why I need 2 points to name intersecting planes? According to the postulate that I just said, according to this postulate. This postulate said any 2 planes, they intersect in a line. So because they are intersecting in a line according to the postulate, and the line intersect on only 2 points, we just say that. So let me write for you the answer. The answer say, according to postulate 1.3, which tells you, says that two distant planes intersect in exactly one line. So you need 2 points to name the line of intersection by postulate. So you cannot just write, you have to say to justify your answer. So let me write them for you. Let me write the answer. That is by postulate 1, 1, 2. So, let's move to the last postulate that we have in this lesson. The last postulate say, through any three non-collinear points, there is exactly one plane. So if you have any three non-collinear points, there is exactly one plane, like this. These are non-collinear points. There is exactly one plane. Let me just discuss with you this example. What a plane contains points N, P, and Q. So just shade it. P, N, where is N? This is N, P, and Q. So they are in the plane that down here. What about which plane contain J, M, Q? J, M, Q, which is this plane. Let's solve the last problem, this lesson. What a plane contain L, M, and N? L, M, and N. So the plane that passes through these points is this plane. Just shade it. This is the plane that include these points. Now, what is the name of a line that coplanar with JK? Let's see, where is JK? JK. I'm going to change the pen first. JK. JK is this line. And KL. KL. So what is the name of a line that is coplanar with this one is JM. So that is the answer. So that is JM. So before I move to the end of the lesson, I would like to summarize the postulates that we just discussed. Through any points, there is exactly one line. Any 2 points, here it must be any 2 points, any 2 points. Any 2 points, there is exactly one line. And if 2 distant lines intersect, then they intersect in 1 point. If 2 distant planes intersect, then they intersect exactly in 1 line. Through any 3 non-collinear points, there is exactly one plane. So that's the end of this lesson. Make sure that you practice. Good luck and bye.